Hello everyone, I am Dr. R.V. Parimala, Professor and Head, Electronics and Communication Engineering Department, Maharaja Institute of Technology, Mysuru. I will be explaining here about the course Introduction to Electronics and Communication, which you will be studying either in first semester or second semester. The title of the course is Introduction to Electronics and Communication. Course code is BESCK 104C. BES representing Basic Engineering Science course, one specifying that it is you are studying in first semester. If you study that in the second semester, then the code becomes BESCK 204C. Course type is theory, and the teaching hours per week, lecture, tutorial, practical, and the final one is project. But here in this course, you will be studying only about theory part of it. The credits reserved for this is 3. In this video, I will be explaining about the syllabus of Introduction to Electronics and Communication. Before explaining the detailed syllabus of Introduction to Electronics and Communication, let's look into the title of the modules, which are 5 in each semester. So, Introduction to Electronics and Communication basically has 5 modules, and those 5 modules are titled as Power Supplies and Amplifiers, Oscillators and Operational Amplifiers, Boolean Algebra, Logic Circuits and Combinational Logic, Embedded Systems and Sensors and Interfacing, Analog Communication Schemes and Digital Modulation Schemes. These are the 5 modules which you are going to study if you happen to study that in first semester or in second semester. When we come to the detailed syllabus of module wise or module 1 now, the first important thing that you are going to study here is power supplies. So what are the power supplies we are going to study? What each power supply is comprising of? When I speak about the power supply, it is the regulated power supply unit which we are going to use it in the laboratory, or maybe a constant voltage source which you are going to use it in the laboratory. So for that, basic block diagram, and it also covers half wave rectifier, full wave rectifiers and filters, voltage regulators, output resistance and voltage regulation, voltage multipliers. So why we have to study all those? So half wave or full wave rectifier converts AC signal into DC, but when it is converted from AC to DC, generally AC is sinusoidal wave, and if you convert it to DC, it will be unidirectional, but it is not complete DC. So if I say DC, DC is always parallel to x-axis, that is irrespective of time, there won't be any variation in the magnitude of the voltage. But when we convert AC into DC using any of the rectifiers, that is half wave or full wave rectifier, the output that we are going to get here is unidirectional. So in order to make it, doesn't change with respect to any time axis, then we need to use the filters. So filters, after using the filters, voltage need to be stabilized, regulated, and it should be at one particular voltage. For that, voltage regulators are going to be used. Then we are also going to study about what is the output resistance and voltage regulation. Then finally, voltage multipliers. In order to increase the output of the power supplies from 5 volts to 10 volts or 10 volts to 15 volts, etc., voltage multipliers are going to be used. Next, in the module 1, you have amplifiers. So amplifiers generally increases the strength of a weak signal. So if it is doing that, how many types of oscillators we are going to have? The type of oscillators, and in that we are also going to study something about the gain, which we call it as output signal to the input signal. So that is going to speak about the gain and also how much it is amplified. The weak signal is getting amplified to what extent, to what quantity. That is what we are going to study by understanding the gain. input and output resistance of an amplifier, frequency response. So with the increase, with the variation in the frequency, how the magnitude or the output is going to change, that we are going to study in frequency response. Once frequency response is drawn, you are also going to find out what is the bandwidth, what is phase shift, what is negative feedback, what is multi-stage amplifiers. That means once the frequency response is done, the next thing is to know about the bandwidth. So bandwidth specifically mentioned till what particular time the signal will be amplified without any distortion and how far the same magnitude is going to remain. That is what is going to be studied under the description of bandwidth. Then you are going to study what is the change in the phase angle from one signal to the other signal, whether it is 90 degrees or 180 degree, etc. You are going to study there. Then the concept called the feedback. The feedback can be either positive feedback or negative feedback. For the amplifiers, we are going to use negative feedback, and the importance of negative feedback you are going to study there. And along with that, you are also going to study about multi-stage amplifiers. So a very weak signal can be amplified to a higher magnitude with the help of different stages of multipliers. That you are going to study multi-stage amplifiers. Next in the module you have oscillators. Oscillators are the one which are going to use positive feedback. Amplifiers are going to use negative feedback, and oscillators are going to use positive feedback. And also, to understand the principle of operation of oscillators, the most important criteria that we are going to study is Barkhausen criteria. So that should be known to each and everybody. Only under that concept we are going to design an oscillator and understand the oscillator. Then what type of oscillator? An oscillator can generate the signal either of sinusoidal or square wave signal or triangular wave, any kind of waveform we can generate it using oscillators. So sinusoidal and non-sinusoidal. Sinusoidal is the one which is following the sine law. Non-sinusoidal is either square, triangular, rectangular, etc. So these type of oscillators we are going to have it. Ladder network oscillator, which is nothing but we call it as RC phase shift oscillator. Vein bridge oscillator is a sinusoidal oscillator. Multi-vibrators, in that we are going to study something about square wave generation and also about the triangular wave generation. Single stage astable oscillator, once again this is going to produce a square wave or rectangular wave. Crystal controlled oscillator is the one which is going to generate sinusoidal signal, and here all these oscillators you are going to study only the concepts, working and the waveforms. There won't be any mathematical derivations. So these are the things we are going to study under oscillators. Then we have operational amplifier. Operational amplifier is a multi-stage amplifier. It has 4 stages, and this is also an integrated circuit because it is having 4 stages, and in different stages you have the amplifier circuits, one connected to the other, cascaded with each other. We call this as IC. It comes in an IC, that is integrated circuit, and this is also called analog integrated circuit, analog IC. Okay. So under operational amplifier you are going to study the different concepts of or the constants of operational amplifier, such as input resistance, output resistance, common mode rejection ratio, slew rate, etc. etc. You are going to study under operational amplifier parameters. Then operational amplifier characteristics if you study. So under open loop configuration, what is the characteristics? Under closed loop configuration, what is the characteristic? How it is going to behave? And if it is closed loop, what kind of feedback we are giving, whether it is negative feedback or positive feedback. Based on whether it is negative or the positive, we are classifying that as inverting and non-inverting amplifiers. And amplifiers for the negative feedback, oscillators also we are going to study under operational amplifier. So operational amplifier configurations basically speaks about inverting and non-inverting configuration, and also we can study about voltage follower there. then operational amplifier circuits. So these are the things which we are going to study under module 2. So module 1 and module 2 basically focuses on the analog electronic circuits. Basically, electronic circuit is classified into two types. One is analog electronic circuit and the other one is digital electronic circuits. So the two modules, whatever we are going to study, is focusing on the analog electronic circuit. From module 3 is now on digital electronic circuits. So for the digital electronic circuit, to understand the different types of gates, much before that we need to study the number system, and under number system you have different types such as binary and then octal, hexadecimal, many more methods are there, but here we are focusing only on the binary numbers, octal, hexadecimal. Decimal is also a number, it also comes under number system. And then we'll be converting the number from one form to the other. That is binary to octal, hexadecimal, or octal to hexadecimal and binary, and vice versa. That's how we are going to do it. So that is what is called number based conversion. Then complements for Boolean expression we are going to have it. So for that complements we are going to study the basic definitions, axiomatic definitions of Boolean algebra, the different types of rules that you are going to study there, basic theorems and properties of Boolean algebra, Boolean functions, canonical and standard forms, other logic operations, and digital logic gates. So once you study the number system, then comes what are the different types of circuits we are going to have in digital electronic circuits. So basically the building blocks of digital circuits are OR gates, AND gate, and NOR gate. So with all the three, we are also going to construct exclusive OR gate, NOR gate, NAND gate, etc. All those things we are going to study here under Boolean algebra and logic circuits. Under logic circuits, we are going to study the different types of circuits such as half adder and full adder. That is why the next subheading here is combinational logic. They are introducing you to what is combinational logic and what are the design procedures. You are also asked to study something about adders, which are half adder and the full adder, using any of the basic gates or using the universal gates. Basic gates are OR gate, AND gate, NOR gate, and exclusive OR gate. The universal gates are NOR, NAND and NOR gates that you are going to study under this module. Then coming to module 4, it is very important module, embedded systems. The mobile phone that you are going to use is an application of embedded circuit, and many more circuits that you are going to come across in your daily life are the examples of embedded circuits. So embedded system is the most important aspect which you need to study. So that comes in our module 4. Under this you are going to study the definitions of what is embedded circuit, what are the things, the different parameters of embedded system, and embedded system versus general computing system that you are going to study there, classification of embedded systems, major application areas of embedded systems. So I told one example is your mobile phone. So like that, embedded system is there everywhere. You take the example of your automatic washing machine, there also you have an embedded system. So wherever you go, you have embedded system or embedded circuit. So those examples you are going to study in detail here. Then elements of an embedded system. What do you have as the embedded system? What are the circuits? Whether I have the programming part there. If it is a programming part, what is the logic I'm going to use it? How do I write the program? Everything you are going to study there. Core of the embedded system, microprocessors versus microcontroller. So these are the two processors which you are going to study. How microprocessor or microcontroller is better than the other. That's what you are going to study. RISC versus CISC. So reduced instruction set computers versus complex instruction set computers. That's what you're going to study there under embedded system. Then the most important thing is sensors and interfacing. Sensors nowadays we use it everywhere. wherever we go, even if you go to any shopping mall, the doors will automatically open as soon as you enter. There is a sensor which senses a human being who is walking in there, so that it is going to get opened. And when no objects are identified by the sensor, then it will be closed. So these are all working based on the sensor that you are going to study under sensors and interfacing. So instrumentation and control system, under that transducers, sensors, actuators, light emitting diodes, 7-segment LED display. These are the things you are going to study, the basics, the very basics of all those things you are going to study under sensors and interfacing. That means you are introduced or exposed to these topics so that in future you can develop on this for your projects, maybe you are using it. Coming to module 5, it's something focused on analog communication schemes and digital modulation schemes. So analog communication schemes, it covers modern communication system scheme. So what are the communication system that we are going to have it right now? Information source and input transducer, transmitter, channel or medium, hardwired and softwired, noise receiver, multiplexing, types of communication systems, types of modulations, amplitude modulation, frequency modulation, etc. You are going to study under analog communication scheme. Then you have digital modulation scheme, advantages of digital communication over analog communications. Then amplitude signal keying, frequency signal keying, and phase signal keying, that is ASK, FSK, PSK. So those are the things you are going to study. Radio signal transmission, multiple access techniques. So these things, even if I try to explain what it is, you may not be able to get it. So while studying, you understand the whole lot of things. After studying all the modules, what knowledge the student would have gained? So that we are going to call it as course outcome. And here we have 4 course outcomes, and course outcome short we call it as CO. So it is CO1, CO2, CO3 and CO4. After completing the analog circuits, you will be able to present a comprehensive knowledge of electronic circuits encompassing power supplies, amplifiers and oscillators. So you will be studying about the power supply circuit, amplifiers and oscillators in module 1 and module 2. So after having studied that, you should be in a position to comprehend about power supplies, amplifiers and oscillators, that is CO1. Next, coming to CO2, that is course outcome 2, you will be in a position to apply the knowledge of digital electronic concepts to realize the combinational logic circuits. So that's using OR gate, AND gate, using along with its truth table and also the Karnaugh maps. Then coming to CO3, present the microcontroller system and embedded system with associated sensors and actuators. After having studied the 4th module, you will be in a position to do the microcontroller system, embedded system with associated sensors and actuators. The last one is to analyze the basic operation and characteristics of analog and digital communication systems. So that you will be able to do it, you will be able to analyze after having studied the 5th module. So this is the expected outcome from the students of Introduction to Electronics. Then once we explain you about the detailed syllabus and also about the course outcome, the next important thing, which are the books you have to refer to, or which are the learning resources we have. So here we are going to suggest few learning resources. So one amongst them is the books. So book you have, it is actually the first you should have the title of the book, then followed by the author, but here it is slightly misplaced. You have Mike Tooley is the author name. The title of the book is Electronic Circuits, Fundamentals and Applications, and it is Elsewhere publication and 4th edition. So this is for the first book. And the second book, you can please understand that Digital Logic and Computer Design is the title of the book. by Morris Mano, the author name. PHI Learning is the publisher name, PHI Publishers, and 2008, the year of publication. Then again you have K.V. Shibu, that is the author name, Introduction to Embedded System, the second edition book. McGraw-Hill is the publisher. Then S.L. Kalkani and Priyanka, the author name, Communication System is the title of the book. New Age International are the publishers. It was published in 2017. These are the 4 books based on the syllabus framed for your course. Then the importance of the course. So it's worldwide. No need to specifically press upon the importance of course, because whichever the gadget you have right now are electronic circuits. Be it your mobile phone or your telephone, or if you go to your televisions or video thing, whatever you have it, everything is having electronic circuits. So knowing about that is very, very important for each and everybody. So it is the leading edge of the world in the present time and also the future way. So you need to study this. Fundamental knowledge of electronic system is essential for each and everybody. Electronics is managed for applications in many major areas including telecommunications, energy and electronic sectors, and so many other fields. So as you have already understood, so it is available everywhere. It's every gadget now, whatever we are using, even a small car, our a kid is using, is having an electronic circuit there. So that way electronics is very, very important and you need to study that. Once you complete the study, once you know the importance of this, the next thing is how the university is going to evaluate that. So evaluation process is divided into 2 parts. The first one is continuous internal evaluation. Throughout your semester, there will be having the assignments, maybe having your internal assessment test, like that. That is continuous internal evaluation. And then finally, after the completion of the course, semester end examination will be there. So semester examination is SEE, CIE is continuous internal evaluation. Continuous internal evaluation is also divided into 2 parts. The first part is internal assessment test. There are 3 tests. Each test will be conducted for 20 marks. So there are 3 tests, so 20 plus 20 plus 20, totally it is 60 marks. Then you have the assignment part. It can be assignment, a project work, or maybe a quiz or anything. So for that 40 marks is reserved. So total marks, it's going to be 100 marks. So out of this 100, you have to score 40%. That means 40 out of 100. But this 100 mark is now descaled to 50. That is, it will be divided by 2. So downsized to 50. When it is downsized to 50, you have to score 40% out of 50. That means 20. If you score 20 minimum, you are eligible to write the examination. Otherwise, you will get NSSR. That means not satisfied sessional requirement. That means 3 tests of 20 marks each and then 1 or 2 assignments. So together it is 100 marks. Out of 100, all those adding for 20 whatever you score. So for each 3 tests and 2 assignment, adding all the together, you should have scored 40 out of 100 or 20 out of 50. If not, if it is 10 out of 50 or something like that, you are not allowed to write the final examination. Then coming to the SEE, that is final examination, semester end examination. So for the semester end examination, it will be conducted at the end of your semester, and that at the end of your semester, it will be conducted for 100 marks. Since there are 5 modules, you get the questions from each module. There are 2 questions from each module, question 1 and question 2 under module 1. So each question is for 20 marks. You have to choose either 1 or 2. So like that for module 2 it is 3 or 4. For module 3, 5 or 6 like that. So you have to select 5 questions out of 10 questions. Each question is for 20 marks. So total marks is going to be 100 marks. So again, the semester end examination marks is downsized to 50. Even here for passing, it is 35%. 35% for 100. Then it is 18 for 50. So remember, think that you have scored 20 in continuous internal evaluation and 18 in the final examination. Together it is going to become 38. If it is 38, you are failed. Actually, to clear a paper, addition of CIE and SEE should be 40%. Though it is 35 marks or 18 to clear the paper in the final examination, but to clear the paper to go to the next semester, it should be 20 plus 20 or 22 plus 18 or 25 plus 18, anything it would be. But you should score total 40% from both CIE and SEE, but minimum for the final examination is 18. If it is 30 in the internal and 10 in the external, again you are failed. So you should have scored 18 in the final examination, 25 or 30 in internal, then it should be passed. So please be clear about that. So with that, I am coming to the end of this session. Thank you so much.